To start today's notes, I want you to go through, and as an Algebra 2 review, you're going to simplify each of these radicals. So either simplify the radical in 1 and 2, or in 3 and 4, you will have to rationalize that as well. What I want you to do is go ahead and try that, and then play the video, and I will talk through how to do it to make sure you know how to do it. One friendly reminder, in Trig, pretty much everything you will do without a calculator, so I would try this without a calculator, because if you just type it in, I'll make sure you know what you're doing. So pause the video and then play it when you're ready to hear the explanation. So what we're doing on ones like 1 and 2 is we need to find the largest perfect square that divides evenly into the radicand, or the number under the radical. So when I look at 147, I want to know the biggest perfect square that goes in evenly. For that, the biggest perfect square is 49. And 147 is 49 times 3. So when I teach this in Algebra 2, I make them write it like that first, especially while we're getting used to it. And then what we can do, we know the square root of 49. The square root of 49 is just a 7. But we don't know the square root of 3, so that stays in the radical right there. And my answer is 7 root 3. On number 2, we do the same thing. Biggest perfect square that goes into 24 is 4. So it is 4 times 6. Square root of 4 is just a 2. So the square root of 24 is equivalent to 2 root 6. But remember, in Trig and in math in general, we always want our answer to be most simplified. So you will always write your answers as 2 root 6, not as the square root of 24. So simplify every radical I ever give you. On 3 and 4, we're talking about rationalizing. And when you learned how to rationalize in Algebra 2, what you should have learned was to first check and see if you can simplify either your fraction or your radical. And in this one, actually, we could do it either way. I prefer to simplify this fraction. So something that goes into both 8 and 24 would be 4. So this is really the square root of 2 over the square root of 5 if you divide a 4 out of 8 and 20. And then we have to rationalize, if you think back to Algebra 2 or college algebra. When you rationalize, you need to cancel out the square root in the bottom by forcing it to be a perfect square. So we want this root 5 to be a perfect square, which means I'm going to multiply it by itself. On top, I'm going to get the square root of 10. On bottom, and I won't always make you write this, you get the square root of 25, and the square root of 25 is just 5. I cannot simplify this because the 10 is in a radical and the 5 is not, so that would be my final answer. Number 4, you do the same way. So again, we're trying to force that 7 to be a perfect square, so I'm going to multiply the top and bottom by itself. On top, do make sure that you distribute this, so this would be 2 root 7, because the 2 is not in a radical, minus the square root of 14, all over the square root of 49, which we know to be 7. You would check to see if you can simplify your radicals, and you would check if there's anything that goes into all 3 terms. In this case, there is not. So that is my final answer. Okay, since I'm gone today, you're going to watch this video to go over the notes. If there's any questions from last night's homework, feel free to take a second and talk through those. Otherwise, we're just going to look through this now. Today's notes is a lot of a review of of geometry, starting with the Pythagorean theorem, making sure that you know what that is. Okay, what you should have learned way back in geometry is that the Pythagorean theorem works in a right triangle, and it has to be a right triangle to work. If you don't have a right triangle, you can't use it. And in that right triangle, we let our legs be represented by A and B, and our hypotenuse, or the side opposite the right angle, to be C. And what we know to be true is that if you take A squared and add it to B squared, you will always get C squared. And again, A and B have to be your legs. C has to be your hypotenuse. This is something that you should be very used to from geometry, but I know it's been a while since you've been in that class. Just to make sure we're good here, go ahead and find me the missing side of this, so feel free to pause the video if you need a second to work through it. And again, on your calculator most of the time I will not, or on your test I will not give you a calculator most of the time, so be sure to be practicing doing this without that help. So, to work through it, here the 8 and the 11 are legs, so those are going to be the A and the B. 8 squared is 64, 11 squared is 121. which if you add that together, that gives you 185. Okay, what that means for us is that my c would be the square root of 185. And you can try to simplify that, but it won't work. If you're wondering how you're going to simplify that with without a calculator, make sure you're thinking about your number sense and things that you know. So looking at 185, 5 clearly goes into that. So I would just try dividing 5 into 185. When we do that, let's see, 5 times 3 gives me 15. That gives me 37. So 185 is 5 times 37. Well, neither of those are a perfect square, and neither of those break down any further to give me any numbers I might be able to simplify. So I would just leave this as the square root of 185. If it's on a section of the test that I give you a calculator and it asks for nearest tenth, you would just type that in your calculator and tell me, hey, that's about 13.6. So be prepared for me to ask it either way, but do be thinking about how to do it without your calculator as well as how to do it with your calculator if that's the case on the test. Go ahead and give this one a try. And again, pause the video, start playing it back up when you are ready to hear the explanation. So in this case, I gave you a leg and the hypotenuse. So say I let that leg be B. And usually we have no problem setting that up. We have no problem squaring the 6. But the problem that we have is how do you square this ugly fraction in the middle? Since all of this is multiplication or division, this squared is going to apply to all of the terms. So what I'm going to do is square the 5 and get 25. When you square root 3, you get 3. And when you square 2, you get 4. So this middle term is really 75 over 4. What I am going to do, since I'm going to be subtracting that 75 over 4 over, I'm going to get a common denominator with this 36 real quick. So this 36 is over a 1. So I'm going to make it over a 4, which gives me 144 over 4. And I know that a squared is equal to 144 over 4 minus 75 over 4, which is the same as 69 over 4. When I square root that, I get the square root of 69 over 2 because you square at the top and you square root the bottom. Again, this one does not simplify, so that would be my answer. If I asked you for a decimal, you can also type that in your calculator, but remember it could go either way on the test. So I would definitely be practicing without, since typically at this point we're very good at using the calculator and less practiced in making sure we're doing it without. So this is something you're going to have to do in each of the problems coming up. So it'll be some good practice. First thing I need to remind you of before we get into that is some trig ratios that you did learn back in geometry. And I will give you 3 more, so if you want to save space in your notes next to these 3, they're going to kind of line up nicely. So just be thinking about that as you write this down. These are the basic trig ratios that you learned back in geometry. Over here on the right, I drew you the triangle that you talked about in geometry, and I've labeled one of the angles. This is called a theta. It is a Greek letter, and we often use it when we get to trig to represent an angle measure, and you're going to see it throughout, so I wanted to show you here. It's really just a 0 with a line through it, is how I will always draw it. And we identify an angle, and then we label our sides based on that angle. So opposite of the angle theta is over here. Adjacent means it's next to it, and then your hypotenuse. And your basic trig ratios are just the different ratios of those 3 sides compared to this theta. So the sine of theta is always opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Back in geometry, you also learned this fun little acronym, SOHCAHTOA, to help you remember it. What you're going to learn today is those are not the only 3 trig ratios. So your geometry teacher may have lied to you if they told you there were only 3. There are actually 6 that we keep from you until you make it to trig. And the other 3 are called our reciprocals. If you think back to your algebra years, a reciprocal is just when you flip over a fraction. So the reciprocal of x is 1 over x. So your reciprocal functions are just the reciprocals of your original. So if you take sine and you flip this fraction over, you get cosecant. If you take cosine and you flip it over, you get secant. If you take tangent and flip it over, you get cotangent. So again, take a minute and write this down. Feel free to pause the video to give yourself ample time to do that. What is going to be super important with these is remembering which function goes with which original goes with which reciprocal. The tangents are fairly easy to remember, as you can imagine. And what I personally remember with my others is that both pairs have both an s and a c. So sine goes with cosecant, you have an s and a c. Cosine goes with secant, a c and an s. But you will have to remember what goes with what. What the bulk of your work is going to be doing today is writing all 6 trig ratios for a given triangle. And so we're going to do some easy ones, some medium ones, and hard ones to really get you used to it. So what we're going to do is write out all of them. So what I always do is I just write a list of all of them. I like to pair my reciprocals with their originals to make my job a little bit easier. So I will make a list much like what you saw on the last slide. Okay, and to set these up, it told me with respect to angle A, which is why I've marked this angle A here, so that makes this 4 my opposite. Makes the 5 my hypotenuse, and this blank side is my adjacent. Anytime you have a missing side in a triangle, there's one thing you should always be thinking of to do, or in a right triangle, sorry, and that is the Pythagorean theorem to find this missing side. So you're going to do your a squared plus 4 squared equals 5 squared, and what you should find is that that missing side is 3. So we do need that in order to actually find all 6 ratios. You would have been able to find 2 of them, but not the rest of them. But then we're just going to go through and write out the ratios. So sine should be opposite over hypotenuse. So the sine of A is 4 over 5. Sine and cosecant should be reciprocals. The nice thing, once I know this first fraction of 4 over 5, I can just flip it over. And I know cosecant is 5 over 4. Cosine is adjacent over hypotenuse. So it should be 3 over 5. Same thing, I automatically know secant now. It is 5 over 3. For tangent, opposite over adjacent, so it is 4 over 3. And then cotangent is its reciprocal, 3 over 4, and you are done. Okay, what I want you to do is go ahead and start to work through this one. This one will be more algebra intensive and will require you to do a lot of things that you did maybe in the warm-up with rationalizing. So start to work it through, give yourselves a couple minutes, and then play the video to be able to listen to me talk it through. Get as far as you can. There's no shame if you can't get all the way through. One hint I will give you as you start it, this hypotenuse should be 9 when you solve for it. So if you don't get 9, take a step back and try again. Okay, I'll start talking through how we got all of this. One thing to notice, they said here angle B, so that's my theta. And so I marked this angle, and when I label my opposite and adjacent, it's important to keep in mind that those have now flipped from what they were on the last picture. If you are struggling with how we got the 9, that should be, you will do square root of 13 squared plus 2 root 17 squared equals c squared. And again, I would do this without a calculator. Squaring the root 13 squared just gives you a 13. When you square root 2 root 17 squared, you get 4 when you square the 2 times a regular 17 because it comes out of the radical, which gives you 68. And that equals c squared. Adding those together gives you 9, which is how I get the gives you 81. When you square root that, that's how I got the 9. Okay, to go through setting up the actual ratios then. For sine, it is opposite over hypotenuse, so it should be 2 root 17 over 9. And again, I just go and find its reciprocal right away, and so I'm going to take this fraction and flip it over. So it's hypotenuse over opposite. But we are not allowed to leave a fraction like that ever, so we need to rationalize it. So I'm going to multiply by the square root of 17, which will give me 9 root 17 over 34, because you do 2 times 17. When I go to cosine, adjacent over hypotenuse is the square root of 13 over 9. And then again, I'm going to do secant by finding the reciprocal of that. And again, you have to rationalize. So my answer is 9 root 13 over 13. Getting into tangent and cotangent will be a little more rationalizing for us. So we have for tangent, opposite, or the 2 root 17 over adjacent, or the root 13. I'm going to multiply by the square root of 13 over the square root of 13, which should give you 2 square root of, when you do 17 times 13, again, you can do that longhand, you get 221 over 13. For cotangent, it's just going to be the reciprocal, so root 13 over 2 root 17. One thing to point out, I always do the reciprocal before I rationalize, because that way I'm having smaller numbers. I'm still going to have to multiply this, but it will make your job easier if you go all the way back to before you rationalize, so the original problem. So that's why I picked just the root 13 and the 2 root 17. But again, we'll multiply this. 13 times 17, we already found out, was 221. And then 2 root 17 times root 17 ends up giving me 34. So these would be your 6 answers to this problem. This will be the last one. We're going to do it the same way. So again, go through and try it. Get as far as you can. There's another little algebra trick in here that we're going to talk about. But take a second to try it. And then listen to the video when you're ready. So when you do the Pythagorean theorem for this adjacent side right here, what you should get is the square root of 131 over 2. Okay, so if you didn't get that, take a second to help each other out. Remember, just like we did on the problem earlier, when we did the Pythagorean theorem, leave it as a fraction, get a common denominator, and combine things together there. But you should get square root of 131 over 2. To do the side of A, I would do the opposite, so the square root of 13 over 2 over the hypotenuse, which is 6. This gives you what we call a complex fraction. And if you remember these from Algebra 2, what we want to do is get rid of this little fraction that's within this big fraction. So what you talked about way back then was, first off, to make sure everything had a denominator. And then we figured out what the LCD was. So between 2 and 1, my least common denominator would be the 2. And I'm going to multiply the top and the bottom of the big fraction by 2. What's going to happen here is that these 2's cancel. So on top, you just get the square root of 13. On bottom, you're doing really 6 times 2 divided by 1, which is just 12. But now I don't have a little fraction inside of my big fraction, so this is much prettier for us to deal with. And this is actually my answer. For cosecant, you really can flip it over either way. So we're doing our reciprocal, so you can either reciprocate your original problem or this one. I would do the reciprocal of the answer here because it is much prettier than this complex fraction and you're much less likely to mess something up. So I would do the reciprocal at this point and flip over my answer. Then I'm going to rationalize it by multiplying by root 13. And then my answer is 12 root 13 over 13. Cosine of A is going to work out very, very similarly. And one thing just to point out to you at this point, this will be a common thing shown up in Trig, simplifying a complex fraction. So make sure, if you're struggling with it, make sure to come see me so I can help you through that. Again, this 6 is still over a 1. So I'm going to multiply by my LCD between 2 and 1, which is a 2. So times 2 times 2. Those cancel, and I got the square root of 131 over 6 times 2 is 12. Divided by 1 is just 12. Again, with secant, we're going to do the reciprocal of cosine. I would flip my answer because that is much prettier to flip. And then I'm going to rationalize by multiplying by the square root of 131 over the square root of 131, which gives me 12 root 131 over 12. over 131. Okay, last but not least, we'll go to tangent. And tangent's a little bit uglier on us here, at least at first. Opposite, so the square root of 13 over 2 over adjacent, so the square root of 131 over 2. You're going to multiply by your LCD, that is 2, and actually both cross out. So here it's the same as just the square root of 13 over the square root of 131. We're going to multiply by the square root of 131 on top and bottom. It's big, but you can do that. You were taught how to multiply. When you do 13 times 131, you get the square root of 1703. And on bottom, those just cancel and give you 131. For cotangent, again, you can technically flip over any part of this problem. I would flip it over after you did the complex fraction, but before you rationalize, because it keeps your numbers nice, a little bit smaller for you. So I would flip it over and write square root of 131 over square root of 13. Then you're going to multiply by the square root of 13. Again, we already know what 13 times 131 is because we did that a minute ago, 1703. Divided by root 13 times root 13 is just 13. And that's it.